Hello everyone, today I would like to introduce a key component of a 6-axis force sensor used in collaborative robots. It is a frame made of 7075 aluminum. The manufacturing process includes CNC milling, CNC turning, and CNC engraving with 3 key technical challenges. First, datum transfer. If the turn datum shifts, parallelism between the sensor mounting surface and the robot front face cannot be guaranteed, resulting in systematic deviation in force and torque measurement. To prevent this, turning and milling share a common locating surface. Concentricity and perpendicularity are re-inspected before transitioning to the net operation. The part proceeds only after verification. The second challenge is the positional accuracy of the hole pattern. The mounting holes, downfill holes, and the sensor fixing holes are all made in one setup. We first choose the downfill holes as reference and then machine the other holes in sequence. The pilot holes of the M1.6 precision threads are all made with tight tolerance. The third challenge, post-anodizing dimensional control. How anodizing alters fit dimensions. The effective diameter of each 7 bolts is reduced, and threads are coated over. Compensation is factored in at the CAM programming stage. Go and no-go gauge inspection before anodizing. Re-inspection after. 2 verification steps to ensure fit dimensions on the sensor mounting surface. Fall back within the tolerance band. The final dimension meets the customer's requirement of ISO 2768F tolerance. The surface finish reaches RA1.6 combined with anodized treatment. We manufacture according to the requirements and make sure precision at every step.